Right, this is review sheet I, question 3, and we're starting off with part A, splitting 4x minus 1 over 2x minus 3x minus 1 into partial fractions. So I'm just going to start off writing that in the right form. So I've got A over the first bracket and B over the second bracket. And in order to work out what A and B are, I'm going to multiply everything through by this denominator. So on the left here, if I multiply everything through by 2x minus 3x minus 1, that's just going to leave me with 4x minus 1. On the right, if I multiply through everything by 2x minus 3x minus 1, here, with the 2x minus 3 on the top as well, they're going to cancel, which just leaves A into x minus 1. And similarly for the second one, the x minus 1s will cancel, which leaves me B into 2x minus 3. So, there's two different ways you could do this. You could either do simultaneous equations, or you could do sneaky substituting in to work out what A and B are. I'm going to go for sneaky substituting in. So what I'd like to do is work out what value of x should I substitute in to make one of the brackets 0. So if you look at this first bracket, if I substituted x equals 1 in there, that would make that bracket 0. So let's do this. When x equals 1, on the left, 4 lots of 1, take away 1, well that gives me 3. We've already said that this comes to be 0, and a lots of 0 is 0. Over here, 2 times 1 is 2, minus 3 is minus 1, so that makes minus 1 lots of b. And solving this, that gives me b equals minus 3. We're going to do a similar thing, if I just read about my working so far. Let's do a similar thing then and work out what we should substitute into the second bracket. So I could go x minus 3 has to come to 0. So 2x would be 3, x equals 1.5. So I could substitute in 1.5, and if you've got a calculator, that seems a great plan. I don't have a calculator with me, so let's cheat and just pick a different value for x. I'm going to pick 0, because it's a nice easy one. So substituting in 0, 4 zeros minus 1 is minus 1. A lots of 0 minus 1 is minus 1, so minus 1a. And b lots of 0 minus 3 is minus 3b. I already know what b is, it's minus 3, so let's pop that in. Minus 3 times b is minus 3 makes plus 9. And rearranging that gives me a equals 10. So to finish off that part, we had to rewrite it in partial fractions. So we need to resubstitute in a is 10 and b is minus 3 in, and that gives us our answer for part A. Alright, on to part B. No puppies this time. So we're trying to find the solution to the differential equation, and to do that we're going to rearrange so that all the y's are on the left and all the x's are on the right, separating our variables. So to get our y's on the left, we're going to divide by this y here. Gives me 1 over y. And then to get my x's on the right, I'm going to divide down by these. So I've got 4x minus 1 over 2x minus 3 and x minus 1, and multiply out with the x on the other side. And as usual, we integrate both sides. So on the left, 1 over y integrates to ln y. Again, I've put the modulus lines because you're not supposed to put minus numbers into ln. On the right, if in part A they've told you to split it into partial fractions, that's a really big hint. You should definitely rewrite what you're trying to integrate in partial fractions. So I've used our answer to part A and replaced this whole part here with this. Probably ought to integrate those, so let's do that. This is going to be a ln integral. I've got a fraction and I'm looking for the top to be the differential of the bottom. So if I differentiate the bottom, I get 2. the top's 10, so it's 5 times too big. So if I have a look at that, that gives me 5 ln 2x minus 3. This one over here, I've got, if I differentiate the bottom, then that gives me 1. I've got 3 times too much, so that's minus 3 ln x minus 1, and again I've used modulus lines, and because I'm integrating there's a plus c on the end of that. The question says general solution, so I don't need to work out what c is at the moment, so that's part B done. And then part C, we're going to substitute in x and y to find the particular solution. So let's have a look at that. Okay, so we were here, and the last bit of information we got is x equals 2 and y equals 9, so let's substitute in. Starting on the left, ln 9 equals 5 lots of substituting 2 in, 2 times 2 minus 3, so that's 4 minus 3 is 1. Take away 3 ln, substituting in 2 again, so 2 minus 1 is 1, and plus c, which we're trying to work out. Let's combine that together using some of our fun log laws. Oh, don't even need to do that, how nice. So ln of 9 is still ln 9. The reason why these have gone to 0 is ln 1 is 0. If you put them in your calculator, you should see that. So c equals ln 9. And rewriting our answer with our plus c in back in here. We've got this. Now we can't actually stop there because in the question it says we need to rearrange it in the form y equals. So now we really will have to do some log laws. So starting with the 5 then, this 5, using the log law where you can pop that up as a power, it ends up ln 2x minus 3 to the power 5. Then taking the 3 up as a power, that gives me x minus 1 cubed there, and still ln 9. Then I'm going to use the rule, well, what happens if I subtract. So if I subtract 2 ln's, that's the same as ln a over b. So I've divided 2x minus 3 to the 5 and x minus 1 cubed. Then I've added ln 9 to it, so if I add ln 9, that's the rule where you multiply together, so I'll get 9 times my fraction, which gives me this 9 here. And then last of all, I want to get those y's by itself, so if I do e to the power of both sides, that gets rid of my ln's.